All right, welcome back, everyone. I said I'd solve this problem, and so this is example in the book. And so what we have is a what's called a transformation, and it's defined by multiplying by this matrix A. And so if I want to compute, as part A is asking me to, what happens if I do T of u? Well, T of u is this vector up here, 2, -1. And when I calculate that, I just need to multiply by the matrix A. So I have this formula that T of anything is A times that anything. So that's A times 2, -1. And then I just need to go through and do that multiplication. And so when I do that, I'm going to do this mentally and write down my answer. I am going to get 5 as my first entry. I'm going to get 1 is my second entry, and I am going to get -9 as my last entry. And so what I'm doing there is I'm doing that swipey method where I do the first row, second row, and the third row. If you're having trouble understanding how to do matrix multiplication, please just send me an email. We can schedule some time to talk in office hours. So let's do part B. It says find an x whose image under T is B. So what that means is we're looking for an x such that if we do T of x, the image would be equal to B. So if I solve that system, well, that's going to mean T of x is equal to the vector 3, 2, -5. And if I rewrite T of x as A of x, A times x, well, that's going to be A, which is this big old matrix here, -3, 5, 7, times x. I'm going to have x1 and x2 in my system. Right? So I'm looking for some vector x1, x2 that solves this equation. Well, to do that, I'm just going to have to do a matrix problem. So I'm going to solve 1, -3, 3, 3, 5, 2, -1, 7, -5. Okay. And when I set up that matrix there and I do some row operations, let's see what happens. 1, -3, 3. Maybe I do 3 times maybe I do the middle row minus 3 times the first, so that's going to be 0, 14, -7. And then maybe I add the first and the third, so I get 0, 4, -2. And you can skip ahead in the video if you don't like watching me do these steps. I can divide by 7, I guess. And I get 2 and then -1. And then down here I get 2 and -1 again. So if I can zero out that bottom row, because I can just subtract it from the middle row. And so I'll maybe do one more step and get 0, 2, -1, 0, 0, 0. And so when I look at this system, I now see it does have a solution. I can solve for x2. x2 is going to equal -0.5. And then x1 is going to equal 3 plus 3 times x2, which is 3 times -0.5. And so that's 3 minus 1.5, so that's 1.5. Okay. And so we did find a solution, and that vector is x1, x2 equals 1.5, -0.5. So that's how we did that. So we found that, and a couple things I could say. I could say that B is in the image or range of T, because I found a vector x that gets sent to B. Okay. And so we've got two parts. Is there more than one x whose image under T is B? Well, that's a good question. Right? So in part B, we found one x that got sent to B. And now the question is there more than one? Well, let's look at the way we solved it. When we solved it, we actually found a unique solution. We had no free variables. And so, so for part C, since we had no free variables, the solution there was a unique solution to tx equals b. So again, the only thing new here is instead of writing ax, we're writing tx, because we're thinking of it as a transformation. And there's a reason for that. There's a reason we're doing that. We're slowly building little bits of abstraction into our problem. And so the last part of the question, let's just zoom up and see what it is. It says determine if C is in the range of the transformation T. So C is the vector 3, 2, 5. And so literally what I'm going to do is I'm going to copy this equation that I've written down here. And the only thing that's different between B and C is that one is -5 and one is +5. So I'm just going to take the same setup that we had here, and I'm going to copy it down, and I'm just going to change this minus sign to a plus sign. And so now when I solve this system, well, everything is the same as before. So I can actually try and save all of my work. Let's do it. The only thing that's going to be different is that instead of that -5, we're gonna get a +5. Okay. And so let's take a look at that. So I'm going to adjust this to be +5, and then when I add those rows together, instead of getting -2, I'm going to get +8. And then here, instead of 2, -1, I think I'm going to get 1, 2. And now, if I continue putting this matrix in echelon form, well, now if I do, let's say the bottom twice the bottom row minus the middle row, well, that's going to be 4 minus -1. I'm going to get a 5 there. Okay. And so I'm actually going to get an inconsistent system, because now in this augmented matrix I have 3 pivots, and so this is inconsistent. So I now have an inconsistent system, and so there is no x such that t of x equals c. So c is not in the range of t. And so thanks for watching this video, and do read sections 1.8 and 1.9. There's a lot of material in there. We'll get to cover most of it in class, but we won't be able to cover everything. So thanks for watching. Bye.